I'm still broke, so no stylus yet. You won't be able to read anything I write. So in this problem, we have a square with side length 6, and then we rotate it 2 times. Each time it's a 30-degree rotation of the previous one, and we end up forming this cool 12-sided shape, dodecagon. And the question is, find the area of the dodecagon. So for our first observation is that all the side lengths are equal, and the reason for this is symmetry, which is always a great way to justify things. Alright, so let's find the side length of this dodecagon. So we'll call this R, because that makes sense. And then R, so then this is R2, and then we have a 30, 60, 90 triangle here because it is a 30, 60, 90 triangle. So then this is R over 2. And now we can draw this thing in, and we know that this is R. And we have more 30, 60, 90 triangles. This is a 30, 60, 90 triangle. And so this is R root 3 over 2. And then this is also R root 3 over 2. And that means that this whole side length here, oh wait, no, this thing. So that just this whole side length here is going to be the sum of these two, which is just R root 3. And then this, wait, okay, I should probably put in right angles here too. Okay, right angle, right angle, right angle, right angle, R, and then this is R over 2. And then this is R, which means that if we write this in terms of R, this entire side length is going to be 3R plus R root 3. And we can set this equal to 6 because we know it's equal to 6. And so if we solve for R, we get that R is 3 minus root 3. And you do this by rationalizing the denominator. Okay, so now let's use this to find the area of the shape. Now, how are we going to do this? We're going to do this by, I can't find my mouse. Wait, where'd my mouse? My mouse disappeared. Wait, okay, I found my mouse, okay. Okay, so let's paste in another shape because that's how life works. Then, let's find the area of the shape. Now that we know the side length is 3 minus root 3, we can use this in an important way. So to find the area of the shape, we'll split our shape into 12, our big shape into 12 smaller shapes, shaped like this. And you see it sort of like cuts in a cake or whatever, so you have 12 of these. And so let's just find the area of one of these shapes as I've outlined, and then we'll multiply by 12. So this is a kite, and the area of a kite is the product of its two diagonals divided by 2, so let's find its two diagonals. So this is 3 minus root 3, 2. And by Pythagorean theorem, we're just knowing a 45, 45, 90 triangle. Wait, I should probably use a straight line for this. Okay. So we know that this length here is going to be equal to 3 root 2 minus 3 minus root 6. So it's just root 2 times like this thing. So we'll point to this, and we know that it is 3 root 2 minus root 6. Okay. So now we have our second diagonal. Our second diagonal is this. And you can recognize that this is just 1/2 of the big diagonal in our, wait, what the, okay. This is just 1/2 of the diagonal of our square. And once again, by Pythagorean theorem, the diagonal of our big square is 6 root 2. So the diagonal of our kite is going to be 3 root 2 here. So we have 3 root 2 here. And now we just want to multiply these together and divide by 2. Remembering to divide by 2 is important. So 3 root 2 minus root 6 over 2, and that's the area of one of these kites, but we have 12 of them in total, and that's going to be our final area. So now we just have to evaluate this. So we have 18 root 2 times 3 root 2 minus root 6. And that's going to be 108 minus 36 root 3. Alright, so now let's go back up and see that this is exactly the form that we got, and ask for the sum of these three numbers, which is 147. So we can circle 147, and we have finished the problem. This problem solution probably made no sense, so you should watch someone else's solution. Okay, bye.